In this video for section 4.2, we're going to start talking about some probability rules. Our first rule is one that we've already seen, and that's that the probability of any event occurring is always between 0 and 1. The probability is 0 if it definitely will not occur, and the probability is 1 if it definitely will occur. Our second probability rule is that the sum of the probabilities of all possible outcomes is 1. So for example, if I'm flipping a coin, I know the probability of getting heads is 1/2, and the probability of getting tails is 1/2. Those are the only two possible outcomes, and 1/2 plus 1/2 is 1. Now, probability rule 2 is written in the textbook in summation notation. Don't worry too much about this if you don't remember summation notation from algebra, but this is just saying that if you add all the probabilities of each outcome together, it will equal 1. Our third probability rule is the addition rule for individual outcomes. The probability of an event is equal to the sum of the probabilities of each outcome in that event. So I can take the probability of each individual outcome and add them together. Let's look at example 4.7. The KQRT radio station plays 4 different types of programming during the 1,440 minutes per day. 540 minutes of oldies, 240 minutes of news, 540 minutes of talk programs, and 120 minutes of commercials. If there is a transmitter outage, what is the probability that it will occur during a news or talk program? So we have 240 minutes of news, and we have 540 minutes of talk programs. So the probability that the outage would occur during news or talk program is equal to the probability that it would occur during a news event, which is 240, divided by 1,440, which is the total number of minutes. And I would add the probability that it occurs during a talk program, which is 540 divided by 1,440. Now the textbook shows calculating each of these probabilities first and then adding the decimals together. I can also add the fractions, remembering that when I add fractions, I add the numerators and the denominator stays the same. So this is 780 divided by 1,440. And if I divide that, I find that it's approximately 0.542. So about a 54% chance that an outage would occur during a news or talk program. Our next probability rule is the complement rule. The complement of an event is represented by the letter, in this case we're using the letter E, with a bar over it. This is the notation that the textbook uses. The complement is that the event E does not happen. So the probability that event E does not happen is equal to 1 minus the probability that E does happen. So let's look at example 4.8. We have a consulting firm. The manager thinks that the probability that a project will result in $0 profit is 0.70. The probability of $2,000 profit is 0.20. The probability of $15,000 profit is 0.07. And the probability of $50,000 profit is 0.03. What is the probability that there will be a profit greater than 0? So there's a couple ways I could do this problem. I could add all the probabilities of the profits that are greater than $0, or I could use the complement rule. So the probability of profit being greater than $0 is equal to 1 minus the probability that the profit is $0. So the probability of profit being greater than $0, profit being greater than $0 means that the profit is not equal to $0. So those are the only two options. Either the profit is $0 or it's more than $0. We're not considering here the probability that we're losing money, but the worst that could happen is that we have $0 profit. So the probability that the profit is equal to $0 is 0.70. So this is going to be 1 minus 0.70, which is 0.30, or a 30% chance that there's a profit greater than $0. Our next rule is for problems that ask us to find the probability of one event or the other event happening. This word "or" is the key word. If we see a question asking us for the probability of something or something else, we use the addition rule. The addition rule is that the probability of either event happening with the word "or" is equal to the probability of the first event plus the probability of the second event minus the probability that they both happen. And the reason we have to subtract that last part at the end is because some outcomes are being double counted. So something might be in the E1 category and in the E2 category, and that means it's being counted twice. So we have to subtract it away so that it is only counted once. So let's look at example 4.9. Greenfield Forest Products manufactures lumber. They're selecting one board at random from their inventory. The probability of selecting a board that is 8 feet long is 0.2222. The probability of selecting a 2x6 board is 0.3889. And the probability of selecting a 2x6 board that is 8 feet long is 0.0833. What is the probability of selecting a board that is 2x6 or 8 feet long? So we see that keyword "or" in our question. So probability of selecting 2x6 or an 8-foot long board is equal to the probability of selecting a 2x6 plus the probability of selecting an 8-foot. Now all boards that are 2x6x8 are counted in both categories here. And so I need to subtract that number so that I'm only counted them once. So probability of 2x6 and 8-foot. Probability of being 2x6 is 0.3889. Probability of being 8 foot long, 0.2222. And then minus the probability of 2x6 and 8 foot. The probability of selecting a 2x6 board that is 8 foot long, that's the "and" part, it's 2x6 and 8 foot, is 0.0833. And if I do that math on my calculator, I get 0.5278. So that's the probability of selecting a board that is 2x6 or 8 feet long, or it could be both.